Welcome students. Let's start lecture number 8.
Practice at 1.3. Question number 1. In figure, angle ABC is equal to 75 degree. State which two triangles are similar by which test. Also write the similarity of these two triangles by a proper one-to-one correspondence. Okay, in this question, we have given a figure. In the figure, triangle ABC and triangle EDC is exist. Triangle angle B is 75 degree and angle D is again 75 degree. So first of all we have to select two triangles. So solution we can write in triangle ABC and triangle EDC. See this. I am selecting triangle A, triangle ABC and triangle EDC. Okay, and I have to prove that these two triangles are similar. Okay, and if they are similar, then from by which test that I have to answer. Okay, so I am taking triangle ABC and triangle EDC. Now the next step is angle ABC is equal to or is congruent to angle EDC. Why? Because these two angles have same measure. So we will comment this angles have equal measure, which is 75 degree, which is given. Okay, next pair is angle ACB. Angle ACB is congruent to angle ECD. ECD. Again, why I am writing this pair ACB and ECD? Because C is a common angle in this case. So I can write here comment common angle. Common angle. So from these two congruency, that is both these two angles are congruent, we can say these two triangles are similar from AAA test. Okay, so finally, because it is very easy, we don't have to check third angle. We don't have to check third angle, as we prove angle B is congruent to angle D, angle C is congruent to angle C again for two different triangles. So we no need to say that this angle A is congruent to angle C. Okay, so this is what the AA test we have discussed. We had discussed this earlier in last lecture. Okay, so finally we can write triangle ABC is similar to triangle EDC. Okay, and the reason is a test of similarity. So, okay, this is the half part of this question is done. Now we have to also write one-to-one correspondence. Okay, one-to-one correspondence is also very important. So in these triangles, A is congruent to E. If you see, B is congruent to D, C is congruent to C itself. It means A is congruent to E. So one-to-one correspondence can be written like one-to-one correspondence is ABC corresponds to EDC. Okay, A is congruent to E, B is congruent to D, and C is congruent to C. Okay, in this way we will complete the first problem. Example 2. Are the triangles in the figure are similar? If yes, by which test? Okay. Again we have two triangles, triangle PQR and triangle LMN. Now they have given sides, the lengths of sides. Okay. For triangle PQR, PQ is equal to 6 unit, QR is equal to 8 unit, and PR is equal to 10 unit. Also, for triangle LMN, LM is equal to 3 unit, MN is equal to 4 unit, and LN is equal to 5 unit. So with this information, we can take, if we take ratio of corresponding sides, let us consider side PQ of this triangle is corresponds to side LM. Simply by looking, we are considering this first of all, and if we take the ratio of these corresponding sides and those ratios are equal, then according to side test, we will say that these two triangles are similar. Okay, so let's start it. Solution: in triangle APQR, in triangle PQR and triangle LMN, PQ upon LM is equal to 6 upon 3, which is equal to 2 by 1. This is equation number 1. Second, QR upon Mn is equal to 8 by 4, which is again 2 by 1. This is the second equation. And the third is PR upon Ln, which is equal to 10 upon 5. So again, answer is 2 by 1. So this is third equation. Okay. So from 1, 2 and 3, from these three equations, we can say from 1, 2 and 3, PQ upon LM is equal to QR upon MN is equal to PR upon LN, which is equal to 2 upon 1. This is from 1, 2 and 3. Okay. So all these ratios, the ratios of corresponding sides of these two triangles PQR and LMN are same. So we can say therefore triangle PQR is similar to triangle LMN. According to which test? According to side test of similarity. Okay, this is what the answer for this problem. Example 3, as shown in the figure, two poles of height 8 meter and 4 meter are perpendicular to the ground. If the length of shadow of smaller pole due to the sunlight is 6 meter, then how long will be the shadow of bigger pole at the same time. Right? Here triangle PQR and here is triangle ABC. Okay, triangle ABC. Such that from this question, PR is the length of pole. Okay, or PR is the pole and AC is another pole. But AC is bigger because it is 8 meter long and this is 4 meter long. Now, shadow of this pole, that is AC, is X, that we have to find, which is large as compared to shadow of PR pole, which is 6. Okay. Now, how to find this? Vertical poles and their shadows always form similar triangles. So, these two triangles are similar. These things we have to understand first. Next step, that is we have to take ratios of their corresponding sides. So if I am saying triangle ACB is similar to triangle PRQ, then QR is corresponds to BC, PR is corresponds to AC, and QP is corresponds to AB. Here we don't need to have the measurement of these sides and this side. Okay, so let's take the ratio of their corresponding sides. In the solution, we can write here AC and PR are considered as poles such that length of AC is greater than length of QR. So pole 1, suppose let us consider this is pole 1, AC is pole 1, then pole 1 is greater than pole 2. Also, QR and BC are shadows of corresponding poles. Okay, as we know, vertically poles and their shadows, as we know, vertically vertical poles rather and their shadows form similar triangle. Okay, hence we can consider or we can say that triangle PQR is similar to triangle ABC or ACB. Now, one-to-one correspondence is very important here. Here, P is corresponds to A, R is corresponds to C, and Q is corresponds to B. Hence, I can write P A Q C and R B. Okay. So, in the next step, we can take ratio of corresponding sides. Therefore, PR upon AC is equal to QR upon BC. So we will substitute those values as PR is equal to 4 and AC is equal to 8, QR is equal to 6 and BC we don't know. Therefore, X is equal to 6 into 8 upon 4. So 4 ones are 4, 4 2s are 8 and 6 2s are 12. So X is equal to 12 meter as everything in meter, so we can write x is equal to 12 meter. And finally, we got BC is equal to 12 meter. What is BC? BC is shadow of pole FC is 12 meters. This is the answer for this question. Example 4. In triangle ABC, AP is perpendicular to BC, BQ is perpendicular to AC, and B dash P dash C and A dash Q dash C. Then prove that triangle CPA and triangle CQB are similar. If AP is equal to 7, BQ is equal to 8, BC is equal to 12, then find AC also. Okay, so let's write those values. AP is equal to 7. AP is 7. Then BQ is 8. BC is equal to 12. Okay, and find out AC. Before that, we have to prove that these two triangles, triangle CPA and triangle CQB, are similar. Now, how to prove this? See, in this diagram, triangle ABC and triangle BQC are exist. Okay. In triangle, if you consider triangle CPA, now see CPA, CPA. It means we have to take this triangle CPA and another one is CQB. CQB. Okay. So in triangle CPA, this triangle, angle measure of angle P is equal to 90 degrees, and in triangle CQB, measure of angle Q is again 90 degrees. So angle Q and angle P are congruent angles because of they are having equal measure. The next pair of angle is angle C itself because this is common in both these triangles. See this C is mentioned. So triangle CPA, in this triangle angle C is there. Again triangle CQB, again in this triangle angle C is also there. So C are congruent to each other because of the common angle. So according to AA test, now we have two angles which are congruent. So no need to check third one, and we can directly say the given two triangles are similar to each other because of AA test of similarity. Okay, this is what the process is. Now let's write down solution. In triangle CPA and triangle CQB, angle CPA is congruent to angle CQB, which is 90-degree measure. Equal measure, angles having equal measure is the comment. Next, angle ACP, angle ACP is congruent to angle BCQ, angle BCQ, which is again 90 degree. So again, equal measure is the comment. So from these two conditions, we can directly say triangle CPA is similar to triangle CQB because of AA test of similarity. AA test of similarity. So this is done. Now we have proved that these two triangles are similar. Now we have to find AC. How to find? As these two triangles are similar, we can take ratio of their corresponding sides. So we have BC is equal to 12 and AP is equal to 7, BQ is equal to 8. So how to take ratio? Okay, if I take AP upon QB, okay, AP upon BQ rather, that is right, BQ. Why I am selecting BQ? Because A is corresponds to B, P is corresponds to Q, and C is corresponds to C. We have to write like this: C corresponds to C, P corresponds to Q, and A corresponds to B. So in this way, it is easy to get the ratio, corresponding ratios. So AP is AP upon BQ, that we can write here, okay, which is equal to AC upon BC. Okay, so reason for this is corresponding side of similar triangle. CSST, just like CSCT, corresponding sides of congruent triangle in the case of congruency, but in case of similarity, we can write CSST. Okay, CSST. You can write like this also. So AP upon BQ. AP is 7, BQ is 8, which is equal to AC, that is X, and BC is 12. In this way, X is equal to 7 into 12 upon 8, 4 2s are 8, 4 3s are 12, 7 3s are 21 upon 2, which is 10.5. And the units are missing, so we can simply write unit. So finally, AC is equal to 10.5 unit. This is the answer for this problem. Example 5 given in trapezium PQRS, side PQ is parallel to side SR. AR is equal to 5AQ, AS is equal to 5AQ. Then prove that SR is equal to 5PQ. Okay. In the given diagram, PQRS is trapezium. Therefore, PQ and SR, these are opposite sides, are parallel. This pair is only parallel, these are not parallel sides. AR is equal to 5AQ. AR is 5 times this side, AQ. And we have to prove SR is equal to 5 times PQ. How to prove this? Okay, so let's solve this. Solution. Here, from given, we can write side PQ is parallel to side SR first. This is a given condition according to the property of trapezium. Then, if we consider SQ as a transversal, see this SQ as transversal, then see this, if SQ is a transversal and PQ and SR are parallel side, then angle PQS and angle QSR are congruent angle because of alternate angle test. Okay, so these two angles will be congruent if SQ is transversal. So here we are considering SP as a transversal. Therefore, we can write angle QSR is congruent to angle SOP or SQP. Sorry, SQP. Okay. Why? Because of alternate angle. The next step, we can say angle ASR. Now see this QSR is this entire side. So if you take angle ASR, this is also same angle, this angle. And if you take instead of SQP, we can take AQP because again A is on the side SQ. So AQP. So let me write this first so that you will understand. Angle ASR is similar to angle AQP. Why? As S, A and Q are collinear. Now we have a two triangles series, triangle ASR and triangle AQP. Okay. So in this triangle, we already proved this and this triangle angles are congruent. Okay, according to this equation. So we can give this name number equation number one. So according to equation number one, these two triangles are congruent. Now if we consider in triangle ASR and triangle AQP, we can write angle ASR is congruent to angle AQP, and the reason is from equation 1. Also we have one more pair congruent, that is angle QAP. Angle QAP is congruent to angle SAR. Angle SAR. That is because, see this triangle first, QAP and SAR. These are the opposite angles. So we can write the comment opposite angle. Okay. So from these two pairs, we can say triangle ASR is similar to triangle AQP using angle-angle test of similarity. So here we have one-to-one correspondence, that is A is corresponds to A, S is corresponds to Q, and R is corresponds to P. See this? A is corresponds to itself here and here. S is corresponds to Q, and R is corresponds to P. Okay. So using this correspondence, I can take ratio of corresponding sides of these two triangles. Okay. So we can write therefore AS upon AQ is equal to SR upon QP. Okay. The reason for this, first of all, I will name this as equation 2, and reason is corresponding sides of similar triangle. Okay, this is the reason for it. The next step, we have already given AS is equal to 5AQ. Okay, AS is equal to 5AQ, that is the given. So we can use that by reshuffling it. AS upon AQ is equal to 5 upon 1. Okay, again I am giving third number to this equation. So we can write here SR upon QP is also 5 upon 1. Why? Because here we have given, here we are right, AS upon PQ is equal to SR upon QP. So if this side, if this is equal to 5 by 1, then this is also 5 by 1. Okay, and so comment we can write here from 2 and 3. But from 2 and 3 we can write like this. And finally we can write SR is equal to 5 times QP, which we have to prove. Okay, so this is our answer finally.